All right, so today's lesson is on reflections. So if you could turn to page 5 of your notes and follow along with me, we are going to complete our lesson on reflections. So the first thing it asks you to do is to define what a reflection actually is. So when you think of the word reflection, you should think of like looking at yourself in the mirror. So what I'm going to do is I'm just going to write down that a reflection is plain and simply just a mirror image. If it lets me write it. So reflection is just plain and simply a mirror image. Okay. Another word for a reflection is just a flip. Because all you're doing is you're taking something and you're flipping it on the other side of a line. All right, so question number 1 asks you to graph the point A, 3, 5 on the set of axes to the right. Before I do anything, I have to make sure that my axes are set up okay. So if you look right here, I have to label this my x-axis, I have to label this my y-axis, and I have to number my axes. Since that's already been done for me, I don't have to do that anymore. So I'm going to go ahead and graph out the point 3, 5. Remember, to graph out the point 3, 5, you just go to the right 3, and you go up 5, and you just put a dot there. So this point right here is my A, and I'm going to label it A. Now let's go ahead and follow the directions. Number 2, graph the image of A after reflection in the y-axis. State the coordinates of the image. So what I'm going to do is, since it's over the y-axis right here, I'm going to treat this y-axis as if it is my mirror, because remember, a reflection is just a mirror image. So I'm going to take this point A, and I'm going to see how do I go from A to my mirror. The only option that I have is to go left, and I have to go left 3. So in order to get to my new coordinate, I'm just going to do the exact same thing. If I went left 3 here, I'm going to go left 3 here again. So this point right here is my new A value. Because this is the new A value, I have to call it something different. I'm not allowed to call this A. So what I'm going to do is I'm going to call this A prime, because that means that it's the image or the new picture of A after I did the reflection in the y-axis. Then it says to state the coordinates of the image. So I'm going to write down the A prime, again because it's new, is -3, because I went to the left 3, and +5. Now you should notice something about the relationship between the original value, or the original coordinates, which is A, 3, 5, and your new coordinates after you reflect it over the y-axis. And we're going to discuss this a little bit more in depth later on. Now let's look at question number 3. Number 3 asks you to graph the point B, 6, 2 on the set of axes to the right. So I'm going to do this in a different color. I'm going to go to the right 6 and up 2. This point right here is going to be my B value. Okay, so since this is B, I'm going to put a dot here and I'm going to label it B. Now let's read what it says on question number 4. Graph the image of B after a reflection in the x-axis. So this time I'm going to treat the x-axis right here as my mirror. So the question is, how do I go from this point right here to my mirror? My only option is to go down, so I'm going to go down 2. So then over here, I'm going to do the exact same thing. I'm going to go down 2 again, and that is going to be my new coordinate. So I'm going to call this point right here B prime because it's my new coordinate. Since I reflected in the x-axis, that's what I did. And then it asks to state the coordinates of the image. So the coordinates of the image are going to be B prime is 6, -2. Now you should notice something about the relationship between when you reflect over the x-axis and when you reflect over the y-axis when you are comparing the original coordinates to the new coordinates. Now, this is something we are going to sum up in your chart soon after we do the next example. So if you could turn the page and take a look at question number 5 right here, it says, given triangle ABC with the following coordinates, I'm going to reflect it over the line y = x. Now, every time I want you to always underline the line that you are reflecting it over so you know exactly what it is that you need to do. And then it asks you to state the new coordinates. So the first thing that I always have to do is graph out my original triangle, my original shape. So in this example, it tells you what A is. A is 3, 1. So I'm going to go to 3, 1, and I'm going to put a dot there. And I'm going to label that A. My next value is B, which is 5, 3. So I'm going to go to the right 5 and up 3. I'm going to put a B there. Now, I'm not labeling my letters quite yet, only because I don't want it to get in the way of my shape. Okay? And then C is 6, 1. So I'm going to go to the right 6, up 1, and that's where my C value is. So this point right here is going to be my C value. So this is C. And I'm going to label this A. I don't know why it keeps changing color on me. Label that B, and label that C. Okay, so now that I have graphed this out, I need to make sure that I connect it because it's a triangle. So I'm going to connect my dots so that I can get my actual triangle right here. So here's my triangle. Now, since I want to reflect it over the line y equals x, it's going to look different than anything that I've done before. So what I'm going to have you guys do is I'm going to have you take a look at this example that I'm about to show you right. So if you take a look at this triangle that you have right here, it's exactly the same triangle that I have you that you had to graph out on your paper. And if I were to reflect it over the y-axis right here, it's just going to take my triangle and it's just gonna put it in the second quadrant, because this right here is the flip of this. If I take this and I flip it, it goes over there. Same thing will happen if I reflect it over the x-axis. It's just going to reflect it into the fourth quadrant. It's just going to flip it down. So if you look at this right here, it ends up looking like this. Now here's where it gets tricky. And before I do this, please just watch. Don't actually write anything down. I'll show you what you need to do once I want you to write something down. So if you look right here, if I were to reflect it over the line y equals x, this is the line y equals x. I'll go over with you how to do that exactly. This time when I do my reflection right here, I can't reflect it up and I can't reflect it down or left or right, because this line right here is diagonal. So when I flip it, it's going to look slightly different. It's actually going to end up looking like that. So the question is, how do I do this? I will show you how to do that right now. Please go ahead, and the next few steps that I'm going to show you, please write these few steps down all the way until the end. Okay, so now we are going to do this reflecting over the line y equals x by hand, just like we did on this program that I showed you. We're going to do it by hand. So remember, the general equation of a line is y equals mx plus b. Okay, but this line right here is y equals x. So what's the m and what's the b? Well, remember, the m is the coefficient in front of the x, so the m is 1. And the b is the added on value right here. There's nothing added on, so I'm going to add 0. So that means that when I graph this line out, I'm going to start at 0. So I'm going to put a dot right at 0. And then I'm going to go up 1 over 1. Okay, so I'm going to go up 1 over 1, put a dot there. Up 1 over 1, put a dot there. And I'm just going to keep going with all of my dots until I've got my whole entire line filled out for me. Now, I highly suggest, especially if you do not have a ruler with you, to draw in every single dot that you can possibly draw in on this graph right here. Once you draw in all of your dots, if you don't have a ruler, find anything that has a straight edge to it and go ahead and graph out your line. So connect the dots with something that would be a straight edge, please. So I'm going to do the same. I'm going to connect my dots right here. So it starts right here, and I'm going to go all the way through, just like that. So there's my line. Do not forget, please, to add in your arrows right here. So I'm going to put arrows here and arrows right here. And also don't forget to write the equation of your line. So I'm going to say y equals x right on the corner right here. Okay? All right, ladies and gentlemen, now this is where things get very tricky, so make sure that you are paying very close attention to this. Because this line is diagonal, there is not one single direction for me to go from this A value right here to get to this line. I could either go up 2 or I could go to the left 2. It's 100% completely your choice. But bear in mind, keep in the back of your head the fact that your choices are to go either up or over to the left. If I choose to go up 2, I'm going to go to the left 2, and I'm going to put a dot there. Because remember, you can either go up or left. If I go up, then I have to go left. If I go left 2, then I would have to go up 2. It doesn't matter. Either way, it brings you back to this point right here, which is your A prime right here. So I'm going to call this A prime. All right? I'm going to do the exact same thing with my B value. So I'm going to take this B, and I'm going to see how do I go from this B to this line right here. It's just like A. It's just a coincidence that it's like A. I'm going to go up 2, or I could go left 2. Remember, you choose one or the other. If I go up 2, then I would go left 2, and I would put a dot right there. If I had gone left 2 instead, I would go up 2. It doesn't matter. Just make sure that whatever direction you did not go originally, you go when you cross the line. So this right here is going to be my B prime. Okay? Then I'm going to do the exact same thing with my C value. All right, so let's go ahead and do with the C value. Same exact thing. Here's my C value. I can either go up to get to my line, or I can go left to get to my line, but it's a different number this time. So to get to my line, I can go up 1, 2, 3, 4, 5, or I could go left 1, 2, 3, 4, 5. If I choose to go up 5, 1, 2, 3, 4, 5, then I have to go left 5, 1, 2, 3, 4, 5. If I choose to go left 5, 1, 2, 3, 4, 5, then I have to go up 5. So 1, 2, 3, 4, 5. It doesn't matter whatever direction you did not go the first time around, you would just have to go the second time around. Then all you have to do is connect your 3 dots together, and then you will have your new triangle. So this right here is my new triangle. Now, there's another way to do this that is a shortcut. I'm going to show you how to do that right now, and you can choose whatever method. Okay, here's the other method that I want to show you. It is quicker, but it's just as tricky, so be really careful. Instead of going up and over, all you have to do is go diagonal. So to go from A to my new line, I just have to go diagonally through one box. So then I have to go diagonally through another box to get to my new point. So this right here is what my new point is going to be. Same thing with B. To go from B to the line, I go diagonally through one box. So then I'm going to go diagonally through another box right here, and that's my new point. Lastly, C is trickier, so be really careful. I would go through 1, 2.5 boxes. So for this one right here, I would go through 2.5 boxes as well. Here's my half of a box, and then here's 2 more boxes. So there's where my 2.5 boxes come from. Okay, so let's go ahead and summarize what we have found right here. So if you take a look at questions 1 and 2, right here, the original coordinate was 3, 5, and then it became negative 3, 5 when I reflected over the y-axis. So the y value stays the same when you reflect it over the y-axis, but the x value changes to its negative, so this 3 becomes a negative 3. Similarly, when I took the b and I reflected it over the x-axis, the x value stayed the same, and the y value is what changed to its opposite. So when you reflect over the y-axis, the x becomes the negative, the opposite sign, and then when you reflect over the x-axis, the y becomes the opposite sign. So if you look at page 3, you should see this chart right here, and let's go ahead and write this out is our information. So before the reflection, it was originally xy. After you reflect it over the x-axis, the x value, remember, stays exactly the same. And then the y value becomes negative. All right. Now, when you reflect it over the y-axis, the x value becomes negative, and the y value stays exactly the same. Okay. Now, let's see what happens when you reflected it over the line y equals x. When you reflect over the line y equals x, the a value, which was 3, 1, became 1, 3. The B coordinate, which was 5, 3, became 3, 5, and the C coordinate, which was originally 6, 1, became 1, 6. So it's very clear that when you reflect over the line y equals x, your x, y just switches spots with each other, so it becomes y, x. Okay? Now, this should make sense to you because if it's reflected in the line y equals x, it means that y is equal to x and x is equal to y. And that's how you do reflections. The chart that's on the bottom of page 6, we are going to fill out together in class next time I see you.
All right, your first video. Congratulations, you're done.